So possible problems in your iOS team. You may take some days to decide in your team what design solution to follow. You have build times and memory leaks because of architecture decisions made in the past. And you also have cumbersome and complex code that takes hours to understand for each developer in your team. Dependency diagrams are here to help. You can gain more time through communication when developing. Dependency diagrams are basically a visual representation of your code. It can help you to validate design decisions, to reach consensus quickly in the team. It enables independent and parallel development. You can diagnose, tie coupling, and retain cycles through the relationship between components or modules. And it's an easy to follow communication standard to reduce time meetings with the development team. So imagine that your boss tells you that a user needs to view some health metrics. We're going to see some code, translate it into the dependency diagrams, and see how we can improve it. You have here a matrix logic controller that is using an API singleton, which in response you have to update the UI and log some events. It also uses a Firebase framework. So you have this dependency diagram that represents the same thing with your code. The metrics logic controller is using Firebase. The metrics logic controller is also using the API singleton, and API singleton is using the callback closure, which is referencing weekly the view controller because it needs to load some events and update the UI. The metrics view controller is tightly coupled with Firebase. This is because Firebase might change or deprecate some of its APIs, and then if this happens, you have to go to the metrics logic controller in order to comply with the new APIs. This might also happen with API singleton, because API singleton might change its APIs, and then if this happens, then you have to go to the metrics logic controller and comply with the new APIs. The metrics logic controller, in order to be compiled, it needs the API singleton and Firebase to be compiled first, and then the view controller can be compiled, meaning that you have higher build times. This is a violation of the singular responsibility principle and also an open-closed principle. Imagine that you have to change the view controller to a SwiftUI view. You might end up with a SwiftUI view that uses a view model and also uses Firebase, and the view model uses API singleton. You're effectively moving all of the logic of the view controller into the view model. You will have higher build times because in order to compile SwiftUI view, you need to compile API singleton, Firebase, the view model, and then you can compile the SwiftUI view. Effectively, we are having the same problems with higher build times, and also we are violating the single responsibility and open-close principle. So let's see how we can do this better. In order to represent the requirements from the business, we will use an abstraction. Say medical metrics loader. Then we need to add some UI kit views, for example. That way we can use a view controller that uses this abstraction. And then you have a remote metric loader to conform to this medical metrics loader to communicate with the backend. You will also have the Firebase metric analytics that also complies with this abstraction. And then you can use a load metric decorator to extend this functionality and compose all of these subjects together. So one of the benefits from this design is that the compilation times are lower because you can compile the remote metric loader, the Firebase metrics analytics, the load metrics decorator, and metrics logic controller in parallel. And it also enables parallel development because you can develop remote metrics loader with a developer and another with the metrics analytics and use another one with the UI. So imagine that you have to change the view controller to a SwiftUI view. We can simply focus on the view controller and change it to a Swift UI view, like this. See that there is no changing into the other components, and it also focuses on only in the UI. I recommend it to do it before starting a feature to get a sense of any issue plan. You can also apply it when you need to diagnose the source of member leaks and rigidity in the system. And you can also use it to visualize what are dependencies used by a component. Note that it might be good for a future documentation, but it requires heavy maintenance. And this is because every time the code changes, then you have to go to the dependency diagram and change it to represent the code. So this is it for this episode. Thank you for watching, and I see you next time. If you want to learn more about this kind of content, but also want to achieve more than 90% code coverage and achieve building times from scratch lower than 10 seconds, please visit essentialdeveloper.com, where you can find a step-by-step program that helps you to become a complete senior iOS developer.